Dear students, welcome back. Today I'm going to start discussing the last part of this topic. I'm going to start enlargement. So again, it's about transformations. Today I'm going to explain what are enlargements and how to enlarge a shape when the center of enlargement is the origin. So our objective for today is going to be we're going to learn how to enlarge a shape from the origin. Okay, so I'm going to start immediately using an example, and I'm going to explain, and then we're going to form a rule from our example. Okay, so let's draw a grid. So I have a grid 0, 1, 2, 3, 4, 5. And again here. Y-index. And we have a shape. We have shape A, and what are we going to do? We're going to enlarge. We're going to enlarge shape A by a scale factor of 3 from the origin. Remember, the origin is the coordinate 0, 0. So, what am I going to do? Now there are various ways how you can do this. I'm going to start by saying that shape A has vertices P, Q, and R, and remember that 0, I'm going to call it O, is the origin. Alright? Now, let's see. So I have coordinate P, coordinate Q, and coordinate R, which are coordinates 2, 1. We have 4, 1, and we have 4, 2. And we've got 4, 2. Okay, so that's P, Q, and R. Now, I need to enlarge from the origin, meaning it is as if I'm going to place a searchlight on the origin, and there will be an image somewhere on the screen right behind the shape. Now I'm going to say from O to P, from O to P, from the origin to P, I am going to move 2 boxes on the X, and that's a movement, and 1 on the Y, and that's a movement. If I need to enlarge that by 3, it means that I need to move on the X 6 times, and I need to move on the Y 3 times. So that will be my new P. So it is 6, 3, and that is my new point P. To go from O to Q, we moved 4 on the X and 1 on the Y. If I multiply that by 3, I'll end up with 12 and 3. 12 and 3 is this point here. To go from O to R, I moved 4 and 2. If I multiply that by 3, I get 12 and 6. 12 and 6 is this point here. So, if I join those dots, I'll get the following. I get that triangle, which is clearly very similar to A. Very similar, they are quite, they look the same, but one is much bigger than the other. Let's see if we're correct. For example, from P to Q, we have a distance of 2. From B dash to Q dash, I have a distance of 6. 2, 3, 4, 5, 6. 2 by 3 is 6. If I check from Q to R, from Q to R is 1. From Q dash to R dash is 3. Again, if I multiply 1 by 3, I get 3. So it seems to be correct. Let's check also. If I take my ruler and I place the 0 of my ruler on the origin, and I rotate my ruler such that it passes through Q, as you can see, the ruler passes through Q and through Q. It should also pass through P and through R. Let's see. Okay, it has also passed through P and through R. So that's one way how to check that problem has been done correctly. Now, what can you notice when you look at these and these? As we can see, we could have immediately took our coordinates, and if we had multiplied our coordinates by 3, we would get our new set of coordinates. So to enlarge a shape from the origin, we can do the following. As a rule, all we need to do is to multiply the coordinates by the scale factor of enlargement. And I am going to do a couple more questions, examples, so that we can understand this. This is not difficult. Alright, so this is a very simple rule. If I have enlargement from the origin, I just multiply the coordinates by the scale factor of enlargement. So let's see another example. Got a shape. So this is the shape. We have a point here. Right, it is the origin. This is shape A. So we're going to do the following. I'm going to enlarge shape A by a scale factor of 1/2 from the origin. Alright? It doesn't matter our numbers, it's going to be easy. Okay? So I'm going to start by finding the vertices, the coordinates of the vertices. I'm going to call them P, Q, and R. P is the vertex -2, 2. Q is the vertex 6, 2, and R is the vertex 6, 6. So I need to enlarge that by a scale factor of 1/2 from the origin, meaning I need to take those coordinates and multiply each one of them by 1/2. Alright? Multiply each one of them by 1/2. So multiplying the first one by 1/2, I will get -1, 1. Q multiplied by 1/2 gives me 3, comma 1, right? Half of 6 and half of 2. This gives me 3, comma 3. So now I go and plot, so it's minus 1, 1, and that is my new P. 3, 1, that is my new Q. And 3, 3, that is my new R. Alright, I'm going to draw the shape now. And this shape, which is now, of course, half the other shape in terms of length, okay, or lengths have been halved. If PQ was 6, now if PQ was 8, now P dash Q dash is 4, alright? If QR was 4, then QR new QR is 2, and so on and so forth. So that is my enlargement. How do I check that it is correct? Remember what I told you. Place your ruler. I'm going now to draw these dotted lines. And if I join P to P, it should pass through the origin. Okay? If I join Q to Q, it should pass through the origin. If I join R to R, it should pass also through the origin. So they have all passed through the origin. So my problem is correct. Okay? This factor of enlargement, this scale factor of enlargement, can be any number. It can be positive, it can be negative, it can be a fraction. Okay, so it doesn't matter. They are all worked out in the same manner. So you should find no difficulty in working out this. All right. Just to give you an example, I could have said, for example, enlarge shape A by a scale factor of -1, for example, negative. It doesn't matter. We had the coordinates P, Q, and R. I'm going to remind you, okay, they were -2, 2, 6, 2, and 6, 6. If the scale factor is -1, I need to multiply by -1. Multiply by -1. If I multiply by -1, what do I get? I get 2, -2. I get -6, -2. And I get -6, -6. What happens if I plot them? So it's 2 minus 2. That's 1. That's the new P. Alright? It is -6 minus 2. That is the new Q. And it is -6 minus 6. That is the new R. Okay? If I draw the shape, let's draw the shape. I'm going to fill it up. Okay, as we can see, that is the enlargement scale factor -1. It's more than just enlargement, as you can see there. It is also a 180 degrees rotation. In fact, a scale factor of enlargement of -1 is the same as a rotation of 180 degrees. A very curious fact. Okay, so that's the end of this lesson today. It wasn't difficult. Just remember the rule. Okay, the rule is very important. And we'll continue this topic in our next lesson. Have a nice day.